Another authentication issue that users really come after you is when they have to have a username and password for all these different applications and services in the network. Asking the user to remember that series of usernames and passwords is going to become overburdensome and can lead to a security risk. I know as an example of the company I worked with in my hometown was a rather large accounting firm, and the chief financial officer that I was working with had and I'm not kidding, I wanted to take a picture of it, but I didn't want to be responsible for the security. But for all of the accounting software packages, he had to have a different username and password, and he had them all written down, or actually on a nice typed sheet with the name of the application, where you find that application to open it, and the username and password, because he just couldn't remember them all. So one way to address this situation is a concept called the SSO, or single sign-on. Now, it's defined as a process for being able to consolidate all of the authentication and authorized functions into one centralized feature. One of the challenges, though, is to manage the diverse platforms through single sign-on. The idea then is that I can have some sort of identity manager that keeps track of all of my usernames and passwords for all of these different things I want to connect to. All I have to do is log in once to the identity manager, and it would then put my credentials in to get me signed into whatever device I wanted to get into. And again, the point there is that they weren't all Windows machines, they were Linux machines, or any variety of different devices that might require a sign-in, and so that's one of the harder things to manage. Now, your advantages of the SSO, of course, is that I no longer have to have the users remembering multiple passwords. I don't want to fully say multiple passwords aren't needed. I mean, we still needed them somewhere if I used an identity type of machine. But if I could find a way to consolidate everybody into the same architecture, the same domain, then now you can have a single sign-on and you don't have to have passwords for everything else. That makes it a lot easier for the administration of user accounts, a lot less overhead of you having to continually reset passwords for all of the different things that people forgot the passwords to. And it also reduces the need to log into multiple different servers as well. I can log into one server, it's got my credentials, and it can authenticate me with all the other devices. The disadvantage is, though, of course, it is difficult to implement across different platforms. The costs associated with single sign-on deployment and development can be very high. And if that one identity that I had that linked me to all those other 20s, if that's ever compromised, then it could be considered a single point of failure for your information assets. When we talk about authorization, which is what you can do, right? So we get past authentication of who you are. Now it's what you can do. We use access rules to be able to specify who can access what. Now, your computer access can be set at different levels for files, for tables, for data items. As an example, at the file level, you would see access restrictions of read, inquire, or copy only, to write, to create, update, or delete only, execute only, or some combination of all of those that we want to give you as far as your access to that item. Now, when we do come across an object we want to access, it's going to have a list of who can access and what their, who they are, of course, the authentication, and what their access is going to be. And that list is called an access control list, ACL. A lot of times we just call it an actual ACL. Now, these files and facilities are usually protected by some mechanism similar to this. And the idea is that it's going to have a list of users, or it could be groups of users, or machines or processes that we're linking up to what their rights are, or I shouldn't say rights, but their permissions, what they're allowed to do. Again, read or write or modify, those types of things. Now, as we take a look at your logical access security administration, it's important to know that this can be administered either through a centralized or a decentralized environment. The advantages of a decentralized environment is that your security administration is on-site at the distributed location. That means they're available for users when they need them. They're there to be able to take care of any incidents that come up. That means your security issues should be resolved in a timely manner, and your security controls should be better monitored and more frequently monitored. But the risk you have is that maybe at that local branch office they say, you know, this is not headquarters. We just don't do things the way you do over there. at headquarters. So we have our own way of doing security, and it works for us. So they might have some local standards that might be implemented instead of the organizational requirements. Also, the level of security management might be below what can be maintained by the central administration. And there could be the lack of management checks and audits because they are so decentralized. There are a lot of ways you can control your remote access to the distributed sites. One is through software controls over the access to the computers or the data files. And remote access, those types of things should be implemented. So what is a software control? Well, we talked a little bit about the access control list. We can also have on the remote access servers, they can have controls that say, who can do or gain access and what time of day can they get there. Maybe it's in my mind or on my profile it says I work all night long, but somebody else that works first shift at 3 a.m., they probably shouldn't be trying to log in. Odds are they might not be up to any good. The physical controls should also be as secure as possible, and physical, of course, means preventing me from being able to physically touch it. Remote access should be controlled appropriately. As I was just saying, if it's 3 a.m. and there's no reason for you to be connected, I'm not going to let you. Now, your controls should also exist for the data that's transmitted from remote locations. Most often, those controls are going to be securing the information through encryption. Replicated files should also have controls that make sure that the files are being used correctly and that they're current. So what's a replicated file? Well, in many file sharing options you have, like distributed file structures or systems, you may have several folder locations that have the same content, so if one goes down, the other is still there. But, as the files are changed, they get replicated, copied. Active Directory, if you have more than one domain controller, you got two or more in your domain, they're going to replicate, they're going to talk to each other. So we want to have controls over those to make sure they're also safe and that they're being used correctly, and I would even say by the right system. Now, remote access is more common in today's use of telecommuters, which is a nice way of saying you work from home, from vendors making connections wherever they are, consultants, business partners. And remote access can connect to the network with the same level of functionality as if they were sitting there in that office. In other words, I can get an address, an IP address and access to that local area network as though I was in that building plugged into the wall. Now, many of these remote access connections are linked to VPNs, the virtual private networks, but this can create holes in the security infrastructure because the encrypted traffic that's being sent back and forth through the VPN is often invisible to the security perimeters. Another way of saying it is, if I made a remote connection to a server, and I had to go through a firewall to get there, but I encrypt that session between me and that server, so now the traffic can't be looked at. Well, the firewall can't look at it either. I mean, it'll see the packet, but the data is encrypted, so it won't be able to see what's happening inside. And that could be an issue. You don't then, can't look to see, am I downloading something I shouldn't, corporate secrets, that type of stuff.